right, number 12 is kind of long, so we're going to do number 12 on a separate sheet of paper. So worksheet 3, number 12. And again, always looking at these 4 right here to think about what we're going to do for a first step. So number 12 is 1 plus tangent squared theta over 1 minus tangent squared theta equals 1 over 2 cosine squared theta minus 1. All right, so right away looking at this, I don't have fractions, so I'm not adding or subtracting fractions, so I'm not going to look for a common denominator. I could factor this as difference of squares, but I'm not sure if that's going to help me yet, so we're just going to hold that in the back of our head. I do have Pythagorean identities, and especially when they have a 1 with them, it's really helpful to get rid of those 1s. And then my last step is changing everything to sine and cosine, or my last, not step, but my last maybe thing to get me going. So right away I notice on my sheet that this is a Pythagorean identity, and it is the same thing as secant squared theta. And again, on the bottom, it's the same thing. Make sure you, or actually it's not, the bottom is this tangent squared equals secant squared theta minus 1. And make sure you put it in parentheses because it's minus, and you want to make sure that you distribute that minus to both. So now what I have is secant squared theta. This is 1 minus a negative 1, which is 1 plus 1, which is 2, minus secant squared theta. So all I've done here on this step is this 1 and this 1 combined to make that 2. All right, so now from here, where to go? So I don't want to go back and replace these with what they just were, so I'm not going to do Pythagorean identities again, because it would just go back to what I was. I'm not adding or subtracting fractions. There's nothing I can factor, so my thought is let's change everything to sine and cosine. So secant squared is 1 over cosine squared, and on the bottom, same thing, 1 over cosine squared. Now I have some fractions, so now my thought is let's find a common denominator down here on the denominator of this fraction. Let's combine these two, so I just have one term down here. So this is, my top is staying the same. On the bottom, this one has a denominator of 1, that one has cosine squared, so my common denominator would be cosine squared, which means the first term needs to be multiplied top and bottom by cosine squared, so that gives me 2 cosine squared theta. And this one doesn't have to be multiplied by anything because it already was over the common denominator. So make sure that you know how to do common denominators for fractions, because that is a huge, huge part of verifying these identities. All right, so from here, it's looking kind of messy. I have a fraction divided by another fraction. So we want to kind of get this looking a little bit neater. So let's actually divide, which means when we divide fractions, we keep the first, we change it to multiplication, and we flip the second. When I do that, that cancels with that, and when you multiply fractions, top times top, which is 1, bottom times bottom, 2 cosine squared theta minus 1, and that is what I wanted it to be, and I am done.